Limitations of Ohm's law. We have discussed Ohm's law, right? Ohm's law state that voltage is proportional to I. So there are some limitations to this Ohm's law that we are going to discuss. Okay, we are just observing ammeter reading, we are just observing voltmeter reading. From that we are drawing graph. Then we are understanding, oh, there are some limitations of this Ohm's law. Okay, so we are going to do that. Limitations of Ohm's law. First one, according to Ohm's law, the temperature should be constant. That is the basic condition. The first condition of Ohm's law is the temperature should be constant. If temperature is not constant, then no conductor is going to follow Ohm's law. That is the first limitation. Temperature should be constant. That is first limitation. Second one, it is Ohm's law. Right here it is V, here it is I, and it should be a straight line. This is Ohm's law. It is an ideal case. Ideal case means it's not going to happen when we are doing the experiment. We are not going to get the straight line. We will adjust somewhere, right? We will adjust the point. We will adjust. We will in the graph paper. We will do some adjustment. The real graph will be like this. Here you can see a bending. When we are using high potential, this is V, high potential. This is high potential. When we are using high potential, there is no increase in current. At high potential, Ohm's law is showing a bending from the real ideal case. At high potential, the graph is not linear. That's a second limitation. At high potential, the graph is not linear. The reason is when we are applying high potential, all the electrons will move with high speed. If all the electrons are moving with high speed, the number of collision will be more. So there will be less increase in current. That's the reason. Number of collisions will be more. Next one, working of diode. In this chapter you no need to learn about diode because we have one chapter for this, chapter number 14, semiconductor physics. In that chapter we will learn this is the diode. When we are observing the voltage current graph of the diode, it is not following Ohm's law. In the case of diode, there are two types of connection. The positive is connected to the negative of the battery, positive is connected to the positive of the battery. Two connections. This is the diode. So we can connect this diode with the battery in two types. One is normal connection, positive to positive, negative to negative, and we can reverse the battery also. We can fix the battery in one direction and we can reverse the battery. So there are two types of connection. That is reversing. So there are two graphs. These are the graph here. Current and voltage. In one case, the graph is like this. It is not obeying Ohm's law. Different. In second case, when we are reversing the battery, this is the voltage and current relation. So in both case, in working of diode, Ohm's law is not obeying. Here somewhere it is obeying Ohm's law little bit, but then also it is not a straight line. So Ohm's law is not applicable for the working of diode. You will learn the working of diode in chapter 14, not now. Okay, so now you write working of diode only. Next one, gallium arsenide. In the case of gallium arsenide also there is a variation. If you are observing the voltage current relation, the graph is like this. It is V, it is I. This is the graph. Here you can see that for the same potential, if you are making a line from here, for the different potential, what is the potential here? This is the potential. At this point, this is the potential, this is the current. At this point, this is the potential, same current. So for the different potential, there are same value of current. Here, these three values are same. This value, when we are observing the current, this value, this is the value of current. At this point, this is the value of current. At this point, this is the value of current. In all these 3 points, the value of current is same, but the potential is different. So gallium arsenide also not following Ohm's law. These are the limitations of Ohm's law. Temperature should be constant. At high potential, conductors are not obeying Ohm's law. Working of diode and gallium arsenide. These are the four limitations of Ohm's law.